Imagine a world without power cords. A world where you never have to untangle a mess of cables or search for an outlet. Your phone, TV, even your car, all getting their juice right through the air. No more plugging in, just seamless power. This is real science called wireless power transfer, or WPT. It's not just a futuristic dream, it's happening now. It's a way to send electrical energy from a power source to a device without any physical wires. Imagine the convenience and possibilities. This technology could completely change how we think about, distribute, and use electricity. It could revolutionize our daily lives. No more tripping over cables or searching for outlets. Your living space could be cleaner and safer. Picture public spaces where your devices start charging the moment you walk in. Airports, cafes, and parks could all be charging zones. WPT can deliver power to places where traditional wires are impractical or dangerous. Think of construction sites or emergency situations. Think about tiny medical implants or sensors in hard-to-reach industrial spots. Wireless power can make these innovations possible. Right now we depend on a massive network of physical wires and cables. It's a complex and often messy system. Wireless power transfer could pave the way for more flexible, adaptable power grids. Imagine a city where power flows invisibly and efficiently. Imagine power hotspots around cities like Wi-Fi hotspots today. You could charge your devices anywhere, anytime. Brilliant engineers and researchers are working on this technology right now. They are pushing the boundaries of what's possible. When we dive into the history of wireless power, one name electrifies the conversation: Nikola Tesla. His groundbreaking ideas and relentless pursuit of innovation have left an indelible mark on the world. Tesla dreamed of transmitting electrical energy wirelessly across vast distances, envisioning a future where power could be sent through the air without the need for wires. He imagined a worldwide system for both wireless communication and power transmission, a revolutionary concept that was far ahead of its time. Tesla conducted mind-blowing experiments to prove his theories, pushing the boundaries of what was thought possible. He built enormous resonant transformers, known as Tesla coils, to demonstrate wireless energy transfer, showcasing the potential of his visionary ideas. His Wardenclyffe Tower project was intended to be the first major step towards a global wireless power network. Unfortunately, Tesla's vision didn't fully come to fruition during his lifetime, leaving many of his dreams unrealized. But his groundbreaking ideas laid the groundwork for many wireless technologies we rely on today, from wireless charging to global communication networks. Tesla's remarkable legacy continues to inspire new generations of scientists, driving innovation and pushing the boundaries of technology. How do we send electrical power through the air? This question has fascinated scientists and engineers for decades. It's based on solid scientific principles, rooted in the laws of physics and electromagnetism. One common method is inductive coupling, used in chargers for electric toothbrushes and smartphones. This technology is already widely adopted in many consumer devices. It works over short distances by creating a magnetic field between two coils. The energy is transferred efficiently within this magnetic field. Resonant inductive coupling allows for power transfer over slightly longer distances. This method is particularly useful for applications like electric vehicle charging. Capacitive coupling uses electric fields to transfer energy between two metal plates. This technique is another way to achieve wireless power transfer. For significant distances, scientists explore microwave power transmission and laser-based systems. These methods can potentially revolutionize how we distribute energy. Microwaves can carry substantial energy over long distances, making them ideal for remote power delivery. Lasers convert electricity into a focused beam of light, captured by a photovoltaic cell. This method is still in experimental stages but shows great promise. These methods offer huge potential for the future, paving the way for a world where power cords and cables become obsolete. Wireless power isn't just a futuristic concept, it's already here. Common examples include charging pads for smartphones, smartwatches, and wireless earbuds. In the medical field, WPT powers implants and sensors without additional surgery. The transportation sector is developing wireless charging systems for electric vehicles. WPT is also explored for industrial uses, like powering autonomous robots and sensors in remote locations. Wireless power transfer holds the potential to make a significant positive difference for our planet and economy. Fewer physical wires mean less raw material usage and reduced environmental impact. Accelerating the adoption of electric vehicles could reduce greenhouse gas emissions. WPT could lead to new industries and job markets, creating high-skilled jobs. It could also lower energy consumption and costs through efficient energy utilization. Reducing electronic waste by eliminating the need for multiple chargers is another benefit. Devices without physical charging ports can be better sealed, increasing their lifespan. WPT could fundamentally change how we design and build our cities and homes. The future of wireless power transfer looks bright, but there are challenges to overcome. Achieving high efficiency and minimizing energy loss is a major hurdle. Cost is another factor. Developing new infrastructure can be expensive. Safety is paramount. Systems must be designed to prevent harmful interference and health risks. Despite these challenges, the future remains exciting. Breakthroughs in materials science and AI could lead to more efficient energy transfer. Perhaps one day Tesla's dream of a global wireless power grid will become a reality. The quest for wireless energy continues.